Okay, so the time has come for us to talk about our third class, being our TP camera class. Now, we're going to handle this a little bit differently than we handled the other two, primarily because TP camera is a lot more sophisticated. There are a lot more things going on. The camera system has a lot of different features, and throughout these videos, we're going to break down each one of those features and have different theory videos and different coding videos over each individual aspect to make sure that everything gets assembled smoothly. Instead of trying to lump all of the theory into one video, as we were able to do with the far simpler TP controller and TP motor classes, we're going to be kind of spreading it out here to make sure that everything is kept as simple as possible. So for now, in this video, what we're going to do is focus on the primary goals behind TP camera and get those ironed out and out of the way before we proceed. So, TP third person camera. Same as before. This thing's going to have some primary functionality and some secondary functionality. Now, what's the primary functionality going to be?
The primary functionality is to take input from the mouse and convert it into orbital information of the camera about a pivot point or a look at target.
We'll say convert mouse input to orbital motion. Around a set pivot object. Which we'll be calling, for our purposes, look at. We'll be looking at that and orbiting around that specific point. Now, this will be a separate game object that we'll end up looking at?
Right. We'll actually name it target look at so we know exactly what we're looking at.
Well, then, let's call it by its real name. I'll erase this very carefully, and we'll call this target look at. Like so. And really, that is it, and that is all for the primary functionality.
It just takes many steps to accomplish it.
Yeah, I mean, by saying it like that makes it sound very simple, when really it's by far the most sophisticated thing we will have done up to this point in the system.
Right, and even when you break it down to its fundamentals, nothing is really complicated. It's just getting all of it to work together that makes it interesting.
Right. We'll do it this way. This is involved. So if anybody asks you about this, we'll just say this is involved, and we'll be talking about each one of the steps. As a matter of fact, here in just a moment, I'm going to break all of that down graphically so that you'll know all of the requirements we're going to put in. But before we even get to that, let's just discuss our secondary functionality. Now, for our secondary functionality, what do we really need to do?
Well, the secondary functionality is going to be a static method that can be called from anywhere that will either take control of a main camera if it already exists in our scene, or if one doesn't exist, it will create that camera and then take control of it. But for the purposes of our design, that will be called from our TP controller's awake method.
Okay. So we'll either take control of an existing main camera or we'll make one and take control of that one. Okay, that's easy. What's not... okay, well, what is still easy but still a lot more involved, again, we had to put the involved stamp on it, is how our camera needs to behave. So what I'm going to do is kind of draw all of this out. So if we've got our little character here, and he's just kind of standing here. Now, let's just consider the camera. Well, we'll do a couple of things here. We're going to have a look at target, which is going to be a game object, and we're going to position that right about the character's head.
Yeah, we're going to embed it right into his brain pan.
And we'll just draw a little arrow to this. So this is our look at target, or target look at, however you want to look at it. That's it, however you want to describe it. Does the same job. Now, we're also going to have our camera. And we'll do our film reels for it. And the camera is always going to be pointed directly at that look at target. Now let's talk about the camera's behavior. What does the camera need to be able to do? Well, it needs to be able to orbit all the way around the player. This orbit can take place unlimited. It just goes around in circles. It's what we do.
Right.
So we can consider this to be an unlimited motion. And by unlimited, I mean we could keep going around and around and around and around and around, never hitting any kind of a wall if we wanted to. Now, we also need to be able to rotate vertically. Up above the character and down underneath as well. So we could have our camera down here, or we could be looking down from up here.
Now this motion we do want to restrict or place a limit on.
Absolutely. So even though we're still looking at our look at target, the problem is we don't ever want to get all the way under here or further, because what would happen if you look at the rotation like this is our camera, and my cameras are steadily getting worse if you hadn't noticed, our camera would end up upside down. And if we were looking out the camera's screen, we would see our character standing there staring at us on the ceiling, and the sky would be out here, and there'd be clouds and trees in the background.
Yeah, probably not the best.
Yeah, it'd be really confusing. And I've actually seen this kind of behavior on some character controllers, and it's pretty awful. It's really, really confusing. So we don't want that, which is why we're going to be establishing some limits. We will establish a lower or a min limit, and we will be establishing an upper or a max limit. So we'll be needing those. Now, that's not all. I mean, we've got our orbiting ability, we've got our ability to rotate the camera up and down, we're always looking at our look at target, but we also need to adjust our overall distance to the character.
Right. If you were to think of this as, say, a tetherball, where you have a rope that attaches the ball to a pole, no matter where you position that ball's always at said distance, and it moves in a big spherical pattern, and always works on an arc. Same thing with our camera. We're going to have a distance from our look at target to our camera, and our camera is always going to move around an orbit that is that distance.
Right. You can think of that distance as kind of being the radius.
Right.
After a fashion.
And we're able to adjust that in this system. We'll be able to bring the camera closer or further away.
Right, so that distance is going to be variable.
Right. And it also has its own limits that you can set. So you can set a minimum distance, and you can set a maximum distance.
So we'll have a max distance, and we will have a min distance.
And to make the whole system seem a little bit more fluid or organic, we've got smoothing that can be applied on each of the motions.
Right, so for changing your distance, sliding in and out, as well as the positioning of the camera as it orbits around, both horizontally and vertically around the character, we're going to be applying some smoothing. And we're going to talk a lot more in depth about smoothing, but the idea, just in really general terms, would be that under the hood, say if we're just talking about rotating along this horizontal axis, kind of orbiting around the character like so, the way the smoothing is actually going to work is that we would just define a new position that we want to go to, and the system we're going to design will smoothly transition to that position.
Right.
As opposed to taking an absolute input and moving to that location on every single frame. By doing that, we end up with a much more natural flowing feel. It almost kind of feels like the camera almost becomes its own character, and it's just doing its best to keep up with what's going on the screen.
Right. And the smoothing that we're doing isn't a true angular smoothing, so it's not following an arc.
Right.
It does kind of cheat and cut corners, and if you dial your smoothing too high, you can actually cause weird motions with your camera, and we'll demonstrate that as well.
Yeah, we'll talk more about what he means when he says that, but in short, the idea is that we're not actually smoothing the rotation angle of the camera.
Right.
The rotation angle is always going to be defined by the fact that we're forcing the camera to always look at this look at target. So that will handle its Y rotation, and that will handle its X rotation. But of course, the Z rotation is going to be ignored because we're not rolling the camera.
Right.
So we're not worried about that. However, the orbiting motion is going to be handled through adjusting the position.
Right.
And that's what we'll be smoothing. It's kind of a fine line because you can still argue that orbital motion is like a form of extended rotation from a distant pivot. But that's not how we're handling this. It's like, if you consider it this way, if you were, go back to the tetherball pole example, if you were holding on to like a tetherball, or if you're just holding onto a rope that was, staked down to a pole, and you were told to move to your left but never let go of that rope, you would always move in a circle. Even though to you, you're just constantly moving to the left. That's exactly how our camera is going to be behaving. So that breaks down all of our requirements, and if you'll forgive me, I just want to kind of list off what we're going to be needing here. First off, we need a set distance. So I'm just going to kind of take this diagram and turn it into a list of all the requirements we've got here. And this set distance needs to be variable throughout play, so that we can change it. We can say, all right, now I want to dolly into only 2 units away from the head, and now I want to pull back out. Next, we need to be able to have unlimited orbiting around the character in the horizontal axis. So unlimited horizontal orbiting, but we need limited vertical orbiting. Also, this guy, and I didn't mention it a second ago, also has limits. So the distance is going to have its own set of limits. Because we don't want to get too close to the character, and we certainly don't want to push the camera all the way through its head or anything like that. We need to be able to pull back to a certain distance. We don't want to get 15 miles away. So that will have limits. We'll have our unlimited horizontal orbiting, limited vertical orbiting. What am I missing? We need to look at target.
Yep.
That all of this can be based upon.
We're going to need sensitivity settings.
Ah, yeah.
Because we want to be able to control the speed of which we're orbiting.
That's right. So we'll have mouse sensitivity, just like you're used to seeing on most modern PC games.
We need to have smoothing factors for each of our variables, meaning we need to have one for distance and one for our X and one for our Y.
Right. Just ways that we can control how that smoothing is being applied. Do we need more smoothing? Do we need to lighten up on the smoothing? Is it taking too long to get from point A to point B? That sort of thing.
Right.
So I think that's everything, though. What am I missing? I'm going back over it. No, we got all of that. We got the horizontal. Yeah, that should be the whole kit and caboodle right there.
Yep. Well, there is one thing, but this is more of a preference that we chose. You do not have to code yours this way.
Oh, you're talking about the button?
Yes.
Yeah. I'll throw that down.
We chose to lock our orbiting of our camera to only happen when you're holding down the right mouse button. Now, this was just a convention that we chose because it simplifies when we're recording so that our world doesn't completely start spinning when we start moving the mouse in our game when it's playing, when we started to change values.
That's right. And if you wanted your game to just always listen to the mouse no matter what so that you didn't have to hold a button, because in gaming world, in gaming land, that could be annoying depending on the game that you set up. Then, of course, you could just opt not to code that aspect in. Right. Don't even worry about looking for the button. Just make everything we're about to code happen on its own. The reason we're doing it, again, as Lee was saying, is it helps for demonstration purposes, though it could be useful depending on the type of game you're making. As I mentioned earlier, if you were designing a game where there were a lot of on-screen elements that needed to be clicked, then you would need some way to delineate when the mouse is in a mode where it should be clicking on things on the screen.
Right, similar to the way MMOs work.
Right.
or if you're looking at some of the RPGs or third-person systems now, where normally you have nothing on the screen until you bring up the menu.
Or another fine example is real-time strategy games, where you got to be clicking on all units on the screen, and then you'll have to click on usually some button to make more units or something. And then the more modern 3D RTS games will allow you to hold down some sort of modifier key, and then as you drag the mouse or move the mouse, you're now rotating the camera's position. And that's exactly what we're doing here. Right. Normally, in a third-person platformer-style game, you probably wouldn't have this. But for our purposes, it does help for demonstration.
Oh, yeah.
Okay, so that's a list of all of our functionality requirements, broken down into a graphical representation, a list of exactly what we need, and of course just covering that basic functionality where TP Camera's main role, its main job in life, is to handle mouse input and convert it into some sort of orbital motion. It's just that orbital motion, as you can see here, has a lot of different factors we're going to be taking into account. And then we have that secondary functionality where, when called upon, the class will either take control of an existing main camera, or if it can't find one, it'll make its own main camera and then take control of that. Which, for the sake of simplicity and to keep things easy to follow, kind of tie up all of our loose ends, that is actually how we're going to begin our process here. We're going to start with the secondary functionality, and we're going to get that out of the way, because that does tie into some of the behavior found within TP Controller, as we've already discussed, just so that once that's gone, we can just focus on these many involved aspects for creating our primary functionality and how the camera is going to orbit. So that's what we're going to start taking a look at in the next video. That's going to wrap things up for this video. Thanks a lot.